Woohoo! Welcome back. I hope you had a chance to get a nice break and, clear your head, go get some exercise, get something nice to drink, hydrate, maybe a yummy snack. And we're coming back, and I realized I wanted to say a little bit more about 6.8, the problem we were just doing. So, to review, we were just looking at this problem where we had two crews working to drywall a house. And at the end, we had gotten the answer 2 and 2/9 days. And I kind of talked us through some things, and I realized I really would like to write them down. So I've made a beautiful, bespoke, handmade. All of my notes are handmade. Ooh, by hand, by an artisanal mathematician. Ooh. You can't, I don't know if you can hear it, but my beard is growing as we speak. This is so bespoke. So I made this for you. This is a labor of love, the old-fashioned way with a pen and graph paper, like they did in, the ye olden times of mathematicians. So, how does the length of the workday affect our answer? It's a good question. So if the workday is some number of hours, what does 2 and 2/9 days represent? So here's what we do. For a lot of people, the assumption is we just assume a day represents 24 hours for whatever reason, because it's simpler. A day officially is 24 hours. So what we would do, pardon me, Sharktopus, I've got my, support carnivores right here. These are my carnivores of the deep, and they're supporting me because I'm thinking of oceans and surfing and Sharktopus, all things that are very, very calming for me. If my workday is 24 hours, then 2 and 2/9, the whole number is the number of days, right? Because the answer is in days, but the 2/9 of a day represents, and then if I multiply it times 24, so I come in here and I do 2 divided by 9, there's my decimal. And some people may ask, well, wait a minute, the calculator is actually not using the whole decimal. It's in fact truncating or rounding. And the answer is the calculator actually knows more about the number than it tells you. It's limited by how big the screen is, but calculators actually have more of the data inside. It's just not telling you because it's figuring you don't need to know that many digits for whatever you're doing. So I'm going to use this, and rather than writing it down, I'm going to take this value, and right away I'm just going to go times 24, and I get 5.333, etc. hours. Pardon me, Sharktopus. Okay, so that's assuming that their usual workday is 24 hours, which if there are some construction jobs where it just keeps going over and over. Over and over. It keeps going through the night. I know nearby, when I live in California, which is right now, the weather's pretty good. You just have to throw up some lights and you can pretty much work through the night because it doesn't get too cold, generally speaking. So, but that does seem kind of weird that it would be a workday that's 24 hours. So maybe a more standard workday might be 12 hours. Well, then 2 and 2/9 days would be 2 days, and then I would go ahead and do 2 divided by 9. Again, it's going to show me part. Oh, sorry, I left it off. It's going to show me part of the answer. It knows more. And I'm going to multiply by 12 hours in a day. And that's going to tell me that this is going to take 2 days, 2.666, etc. hours. Okay. So if I were a student, I'd be like, whoa, how is it that you're getting two different answers and they could both be correct? And the answer is, well, the problem with this particular problem when I wrote it, and I wrote it on purpose this way, so that we would have some wiggle room so we could talk about it, is it's not well defined. And so if I just say 2/9 of a day, you don't know what a day counts as. Is it the full 24-hour day? Is it just the work day? You don't know. So if we assume it's the 24 hours, then 2/9. 2/9 is a little bit less than a third, right? And actually, it's 2 times 4 is 8. It's not even a quarter. It's a little bit less than a quarter of a day. It would take 5 hours, a quarter of that day. If they're only working 12 hours, it's about a quarter, a little less, so 3 hours, so 2.6 hours approximately. And if their workday is considered 8 hours, then we would take the 2 divided by 9ths and multiply by 8. And we get 1.777, etc. hours. So when we're saying it will take 2 whole days plus 2/9 of a day, slightly less than a quarter of a day, we have to ask, okay, but crew, what is your day? Are you working a full 24-hour day, a 12-hour day, an 8-hour day, less than that? So this is an example of how not knowing how things are defined makes it hard. And again, 2 2/9 days is the correct answer. So as long as we don't try to get fancier than that, we're good. And then we need more information to keep going. That was it. I wanted to write that all out. Okay, so now you all can wake up. And yeah, I hear some snoring in the back, I think, which is probably me. I probably fell asleep during that last bit. Shall we do another problem? Yay! Oh my gosh, this is so exciting. We've got 2 crews. Well, they're going to be working together. And we're not going to tell you how long it takes each of them. No, this is exciting. 2 crews working together can drywall a house in 2 days. So working together, time equals 2 days. Working alone, the faster crew can drywall a house 3 days earlier than the slower crew. Does that make sense? The faster crew can drywall a house 3 days earlier than the slower crew. Oh my gosh, this is suddenly getting very complicated. So let me walk you through how I think we should approach this. I'm going to say the faster crew alone is going to take T days. The slower crew alone is going to take T plus 3 days. And you're going to say, whoa, 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 where did the 3 come from? And I'm going to say right here. So in other words, I've got 2 ways of looking at this problem. Either I can say the slower crew takes an extra 3 days, or the faster crew is 3 days faster. Now, personally, I try to avoid minuses. I don't really like them. And I know that's a pretty big bias for a mathematician, but I don't like them because they tend to complicate the problems for my students. And so if I'm going to choose, I'm never going to choose to go with the minus option. However, if you would like your alternate setup, for number 3, would be that the faster crew alone if I can spell alone, you can tell my brain really doesn't want to do this. And the slower crew, okay, now that looks like a really weird word now. I've written it too many times. I could set the slower crew to T, and the faster crew is T minus 3. You see that distinction? I got 2 options how I want to set this up. I could set it up as a T minus 3 for the faster crew, or I could set it up as a T plus 3 for the slower crew. Now, what is the big real difference? The real difference is that here I've set T to be the faster crew. That's they own the T. Whereas in this version, the alternate setup, the slower crew owns the T. I don't care which way you do it. I prefer this way, but you can do it this way. And in fact, you could watch this walk through here and then try this version just to see, to make sure you got it. Okay, so those are your options. I'm going to go with this one. So far, so good? Okay, now remember, if I know the time, the rate is equal to the quantity over the time. So the faster crew and then it's one house, because again, we're doing the same, how long does it take you to drywall a house? One house is going to take, the faster crew for me is T, equals 1 over T house per day. On the slower crew, and now their time, this is the time. These are times right here. Right. Oops, sorry, you can't see that. Let me move my calculator to get it out of the way. There we go. Sorry about that, shark. It's okay. Okay, shark is okay. Shark's great. Shark, in fact, this is a shark that just likes to be up near the surface, you know, Jaws style, like nee, 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 nee. Oops, sorry. Nee, 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 nee. Okay. Oh, you know, do you ever start out singing Jaws and end up singing Star Trek? Yeah? No? Doesn't happen to anyone else? Okay, just me? Okay. That was the Star Trek battle song I went into. Obviously, this is some exciting stuff going on right now. Okay, so these are the that's how long it takes them. And remember, these problems, the hallmark is we get told the time and we have to figure out the rate, and the rate ends up being a fraction. And that's why this is in 6.8 and not back in chapter 3 when we started doing these kind of problems. So, okay, so slower cruise rate is going to be one house per, oh, you know what I didn't do? Let me write days down here. T plus 3 days. So that's 1 over T plus 3 of a house per day. So far, so good. Now, a little note about the actual English involved. As you can see, I play fast and loose with my language because I just do. Down in the denominator, I find that T should be plural because we're assuming that it's taking multiple, so it's a plural. But whenever you say per, you almost always leave this as a singular. So you'll notice that I wrote that as T days, and then suddenly it's house per day. It's just convention for us. So, you know, and I'm sure a lot of you understand linguistics a lot better than I do. So, you know, take with a grain of salt, and I apologize if it's too weird the way I do things. Okay, so I've got a rate here. I've got a rate here. So I know how fast the faster crew works, and I know how fast the slower crew works. And then I've got one other piece of information. I want to go back up here and say, I'm going to use pink. Up here, together, they can drywall a house in 2 days. Okay. So, working together, the time is 2 days. So, I'm going to set this up exactly the same way that I set up the previous one. Let me show you this. I'm going to bring this in. Remember here where I said crew 1 plus crew 2 equals one house? So they're working together to finish one house. I'm going to set that up again, except instead of crew 1 and crew 2, I'm going to use fast and slow. So fast crew plus slow crew are going to finish one house. Okay. Now, the time is going to be 2 days. So the fast crew, remember the quantity Q. Where's my card? There are two big formulas we're using. This I'm going to use quantity equals rate times time. So the quantity that the fast crew does is the rate of the fast company times the time of the fast company. The slow crew will have the rate of the slow crew times the time of the slow crew, and that's going to give us one whole house. The fast crew's rate is 1 over t, from right there. The slow crew's rate is 1 over t plus 3. And all we have to do is put in the time. How long are they working? Well, if we go back up there, they're going to work together for 2 days. So this is kind of interesting. It's a little different than the other one. So we're going to work together for 2 days. This is the time working together. Okay, so far so good. Now I want to take a break here and say you're awesome and amazing. And these particular problems are wickedly difficult. They really are. These are not obvious. These are not intuitive as far as I'm concerned. I think some of the stuff from chapter 3 you can kind of like figure out on your own. I think this really requires a lot of practice. So again, I'm going to want to encourage you that if you go through all the practice in the homework, which I tried not to assign too much because these problems can take an hour each. So I'm trying not to give you a million of them. But if you exhaust the problems in the homework and you're like, I really need more practice, I can write more of these for you. They're very quick for me to write. So if you'd like more, just ask. I know it sounds ridiculous. Everyone's like, what? I don't want more. I'm barely finishing the homework you give us. I know. I'm going to go ahead and copy exactly what I have. I'm not going to make any changes. And notice that I am now using even more space than I was before. Because whenever fractions come in, you should always have your support crew there to tell you you're awesome. You are awesome. Remember that you're awesome. Math on, but also write big, because that way things don't accidentally disappear. Okay, at this point, we no longer have a word problem. We have an equation with that involves fractions. So in other words, rational equation. Okay, so I'm going to rewrite it. 1 over t times 2 is 2 over t. 1 over t plus 3 times 2 is 2 over t plus 3. And the whole thing equals 1, and I need an LCD. Now you'll remember in the previous problem, if I can find it, in the previous problem, the t's were on top because the question was how long does it take for them to work together? And here we know it takes them 2 hours. We just don't know what their rates are. So it's reversed, what we know and what we don't know. Notice the LCD was just to multiply the two of them together. That's going to be exactly the same approach this time. I know. Everyone's like, oh, no, please don't. Yes, we're going to do it this way. Everybody's going to get one of these. So imagine Oprah here saying, everybody, look under your seats. You get a t times t plus 3. You get a t times t plus 3. You get a t times t plus 3. Everybody gets a t times t plus 3. That's a lot. Okay, what colors have I already used? I've already used pink, and I've already used blue. Okay. So let me go ahead. I can go ahead and use yellow in this case. Notice, trying not to take you to Smeary Town too much, but notice that everybody gets a T and a T plus 3, whether they want it or not. I know, this is one of those Oprah's favorite things where one of Oprah's favorite things is like something you really don't like. But you get it. Everybody gets one. Okay, so I'm going to cancel the T. Remember, the goal is not to make your life perfect. It's just to make the equation more comfortable. I think a lot of people would rather not deal with these fractions. So that's the goal here. Now, if you don't mind working with fractions, go for it. You do it. You do you. Notice over here we've got times 1, so we just get that out. I'm going to go ahead and use distributive property now. 2t plus 6 plus 2t equals, and then here again distributive property, t squared plus 3t. Okay, so now you can see why the rational equations came after our study of polynomials, because now you know, okay, we've got this nice thing, and it is better. It no longer has fractions. Yay, yay. But now it has t squared, which means we're dealing with a quadratic, which means we're looking to either factor or use the quadratic equation or quadratic formula. So I'm going to move everybody over onto the right because I'm going to preserve my t squared being positive. That's my choice. You guys can do what you like. Before I even do that, though, I noticed that I've got a couple of terms I can combine. So let's clean this up. 4t plus 6 equals t squared plus 3t. This little guy right there, t squared, means move all terms to one side. That's what t squared says. Okay, so I'm going to move it over to the right. I'm going to subtract 4t, subtract 4t. I get 6 equals t squared minus t minus 6 minus 6. 0 equals t squared minus t minus 6. Could I have subtracted them both in the same step? Absolutely. If you're comfortable doing that, do that. So far, so good. Woohoo. Okay, again, I'm going to transfer it to a new sheet. I'm going to copy it exactly and then play with it in the next step. 0 equals t squared minus t minus 6. Okay. Woohoo. Sorry about the ring light. It really is a magical thing. It lights up the world. Okay, so how are you doing so far? Take a deep breath. Woohoo. So we come over here and I say, now, what would you like to do? We've got a quadratic equation. So we got a t squared, which means we got two choices. Factor or quadratic formula. I would encourage you to factor this because I think factoring is very quick and the quadratic formula on this is going to take you a silly long time. Can you use it? Yes. But can I convince you because it's t squared? We can break it up as t and t and then we think, anyone else have dynamite playing in their head? No? Okay, just me? Okay. It's t and t. Minus 6, I need to get to negative 6. So negative 1 times 6, 1 times negative 6, negative 2 times 3, 2 times negative 3. I'm thinking of my options. I'm thinking of a minus in the middle. I'm going to go with negative 3 and positive 2. Does that work? Kind of woohoo. Gives us a negative 3 plus 2 in the middle, so that's the opposite of t there. And when I multiply negative 3 times 2, I get negative 6. Woohoo! Yay! Okay, now what's the next step? Do you remember? Because when you use factoring, you have to do the work yourself. Quadratic formula does everything for you. That's the one benefit. It takes forever, but then it's done. It's like a really long microwave problem, as opposed to doing it from scratch. So this one says I either set up t minus 3 equals 0 or t plus 2 equals 0. So either t equals 3 or t equals negative 2. Right? Because we use the 0 property. Nice. We're almost there. Now, why does math give us these two answers? Well, the math was right here. This is the problem we're solving. This equation models what's happening in the real world. But when we actually look back on the problem that we set up in the real world, let me find it. Sorry about that, Sharktopus. The problem that we set up was that, there we go, the faster crew alone was working for T days. This doesn't make any sense. -2 days? Nope. So we say, you know what? That's not possibly an answer. It is a solution to this, which models what's happening, but it doesn't actually make sense in our time and space, right? We don't know what it means for it to have taken 2 days in the past to do it. So what we're going to go with is T equals 3 days, which is, we look up here, the faster crew. And how do we know? Well, because we wrote this out so that we would have notes for ourselves. Because we knew that after 2 or 3 pages, we would completely forget. Like at this point, you probably don't remember your own name. I don't know your name. I don't even know my own name. I don't even know what time it is. I don't even know where I am. I know this is Sharktopus and we're almost done with the problem. That's really what I know, and that's what's exciting. So then I use this to say, okay, T was the faster crew, and so the slower crew was going to be T plus 3 days. Okay, so this is a little confusing because my brain sees the 3's. Ignore that. It's just coincidence. So T is 3, so that's equal to 3 plus 3 equals 6 days. So the faster crew and I'm sorry, I'm confusingly capitalizing the alone. I'm emphasizing. So the faster crew working alone would take 3 days. The slower crew working alone would take 6 days. And interestingly enough, the two of them together takes only 2 days, which is kind of cool. So I should say working alone. Should I add this in? Working. There we go. Woohoo. You guys are so awesome. And if you do still remember your name, nicely done. If not, go out, find the sunshine or even the rain, get some oxygen, get a little exercise. You guys are awesome for making it through this problem. This is probably the hardest word problem. This type of word problem is the hardest kind we have in algebra. So pat yourselves on the back. You guys are awesome and amazing and wonderful. And that's it. This is going to end chapter 6. Woohoo! Very exciting. And so woohoo, and have a great day. Math on. Continue to be awesome. I'll see you next time I see you. Woohoo! Bye.